I mean, there is certainly wide variation in rates internationally, of which a fair amount of it is really likely to be environmental factors rather than, genetic factors, in part based on migrant studies where people move to another country with different rates, and within a generation they tend to, assume those rates. But that said, there are some differences. There's also there's well-known racial differences, for example, in terms of the types of breast cancer and rates of breast cancer that occur. So there are a number of differences.
Yeah, maybe I could expand on that. One of the areas is it looks like in African American women have somewhat fewer cancers, but they have worse cancers. And I should say that now with genetic markers, we're able to characterize where the ancestry admixture of various individuals. One could imagine that this is very sensitive information, and especially in an African American population where there's substantial admixture. So like in European, Caucasian population, there's like 1 or 2% African admixture, but in African Americans, there's a tremendous range of African American heritage, as one could imagine, because of the slavery, the integration, all that. So sometimes these become very sensitive in terms of presenting information, where when you're trying to define African American, say, ancestry, or a specific country of origin ancestry, because that's saying where you came from. And of course, our idea about our identity is in the United States is self-identity. We're able to identify on a census as any race, ethnicity we choose. And so it becomes very sensitive from somebody telling you it's a different thing. So that becomes an issue in science as well.
There are three other parts to your answer that I'd give you. First of all, there are some very unique populations that have extraordinary incidences of breast cancer, or certain kinds of breast cancer that we have no understanding exactly why. Tunisian women who have a huge superabundance of inflammatory breast cancer, another sect in India, and we don't know why. Efforts to uncover that have been unsuccessful. The second point is, so let's understand genetics for a minute. We always say breast cancer is genetic, but there's two kinds of genetics. There's that which you get from your mommy and daddy. Think about eye color. Not everything you inherit is genetic. There's money too, but there's that kind of obvious yes or no genetics. Blood type. If your mother is type A and your father is type A and you're type B, there's something very wrong here. Then there are genes that don't quite dominate the show, but just contribute a little bit, maybe 2%, 3% to a trait. And many people carry variations in common genes in which minor variations, the word we use is SNP, confer a bit more or a bit less risk. And those SNPs are often arrayed differently in different populations, Asian populations, people from some region of the world, Spain even, or Finland. All of these have, because of much more intermarriage, there are more Finns in Finland than there are in Italy. So that they tend to preserve those SNPs in those populations so that they may have different kinds of risks. The third piece, which I wanted Jimmy to talk about, is that variations in people's genetics have everything to do with whether drugs work or not. Somebody gives you a dose of a drug, and you hope it's the right dose, but if you measure drug levels and people are getting ampicillin, okay, something like ampicillin, which most of us have had, well, it turns out that many of you will have just the right levels, but some of you won't clear it right, and you'll have higher levels, which usually isn't a problem, but could be. And some of you will clear it too fast and won't have much ampicillin at all, and your infection will kill you. So those are often genetically determined and quite different amongst populations. Would you like to comment about that, Jimmy, now that I've set you up here?
Yeah, so this is my area of research, and what happens in general is that we have this one-size-fits-all when we think about drugs, but what you think about is that in our livers, there's enzymes in our livers that are there to protect us from xenobiotics, protect us from drugs. So when you take a drug, it eventually gets eliminated. But these liver enzymes have these SNPs, in them, and it changes the way people respond to drugs. And so what we're really trying to study is using a genetic approach, not only from, the benefit from the drug, but also, I'm a pharmacologist. I always say every drug is dirty, every drug has side effects, and you want to maximize the risk versus the benefit for the individual patient. When you're trying to use a genetic approach, so by understanding these liver enzymes and the genetic variants, we predict whether or not patients will respond. And Mark, brought up the point about, in these issues with ancestry as well, is that, we've run into problems. We do a lot of research in the lab, and one time where I had a technician who's in there, and we study these enzymes, and I say, oh, these genetic variants, you need to study them. And so he goes home and he genotypes his wife, and she has a particular genotype, and she's homozygous, so you got 2 variant alleles. He goes to his in-laws and gets blood samples and genotypes his in-laws, because, oh, this is important. His father-in-law and mother-in-law should know whether or not they have these genetic variants. And this was a situation we ran in where this makes sense. It's definitely the mom. And oops, we have a problem here. This is why we have all these federal regulations and laws. You don't play around like this. This gets you in trouble. Don't make the PI sweating bullets like this. So,
Or you can go to 23andMe and do it yourself.